Good morning, students. We are seeing now the integrated rate law for gas phase reactions. Now there are gaseous reactions also as that of the solution reaction. So we have to see here the integrated rate law for the gas phase reaction. As we see last the integrated rate law for the solution reaction. Now suppose our gaseous reaction, gas phase reaction is A gas gives B gas plus C gas. Here A is the gaseous reactant and B and C are different gases as the products. Now let initial pressure of gas A is Pi. That is the initial pressure of gas A, and that decreases by X quantity or by X pressure within time T. That means after time T, X pressure of the initial pressure of A decreases. That means after some time, after time T, the pressure remaining will be Pi minus X. So the reactant pressure of the gas at time T, that is the reactant pressure of gas A at time T remains is, now this is the reactant pressure of gas A, Pa is equal to Pi minus X. X quantity of pressure get decreases after time T. So the remaining pressure of A after time T is Pi minus X. Now suppose this is the equation X. Now then the pressure of the product gas B and C at time T. What are the pressures of the product gas B and C at time T that are equal, and Pa is equal to Pc, that is equal to X is the pressure of the product gases B and C. Then the total pressure of the reaction mixture at time T, because at time T there are the three different gases in the reaction mixtures, A gas, B gas and C gas. So the total pressure of the reaction mixture at time T is, suppose that is P, the total pressure is P, and that is equal to Pa plus Pb plus Pc. That is the pressures of reactant and product gases after time T, and that are, now this Pa is equal to Pi minus X and Pb and Pc is equal to X plus X. Now it becomes Pi plus X because this X and this X get cancelled. So the total pressure P is equal to Pi plus X. Here we have to calculate the pressure X which get decreased. So X is equal to, now this X is equal to this P minus Pi. This Pi gets minus from this P and X is equal to P minus Pi. Now this is our equation Y, suppose. Now we have to calculate here only the reactant pressure, Pa by substituting this value of X in this equation X, because we have to obtain all these that pressure Pa in the language of pressure. Now see, substitute the equation Y in equation X, then what we'll get? Pa is equal to this Pi minus this value of X is P minus Pi. Substitute here the value of X as P minus Pi in this equation X. So Pa is equal to Pi minus, in bracket, P minus Pi. Now it becomes Pi minus P plus Pi. Now this Pi plus Pi twice Pi minus P. Now this is the pressure of the reactant gas after time T, the PA, reactant gas A, the pressure is of that gas is PA, that is equal to twice PI minus P. Now we have to substitute all these value of initial pressure, pressure after time T of the reactant in the integrated law equation of that solutions, as that of initial concentration in that equation is A0 and concentration at time in that equation of the that is the reactant is AT. So substitute the A0 by Pi, initial pressure of the gas A, and substitute the pressure, concentration of A, that is the AT after time T, by twice Pi minus P, and then we will get the integrated rate law for the gas phase reaction. Now see this. Now see students how the integrated rate law of gas phase reaction becomes here. Now the integrated rate law for solution reaction we already that seen is given as K is equal to 2.303 divided by T log to the base 10 concentration of A, initial concentration of A, A0 and concentration at time T is 80 of that reactant. Now this is the integrated rate law for the solution reactions. Now substitute concentration of A0, that is the initial concentration of the gas A. Now Pi, here is the pressure because it is the gaseous reaction. So initial pressure is Pi. So substitute A0 is equal to Pi and AT is equal to twice Pi minus P because it is the pressure of gas A after time T. Now as it is the gas phase reaction, so the concentrations are replaced by the pressures. Now K is equal to 2.303 divided by T log to the base 10 Pi divided by twice Pi minus P. Now this is the integrated rate law for the gas phase reaction. See that rate law.